When organizations adopt new technologies, the context of that technology plays an important role. How people deal with the material properties of the new technology is informed by their previous experience of using or not using similar technologies in the past. Since blockchain is still a new technology, how organizations adopt this technology also depends on how existing and related challenges are resolved. These affect how organizations apply blockchain and smart contracts and whether the design and decision-making capabilities within will or can change at short notice. Currently, many enterprises are experimenting with blockchain, but few have implemented a decentralized solution. According to a 2019 Deloitte report on enterprise blockchain adoption, 53% of 1,386 interviewed executives stated that blockchain had become a critical priority. However, only 23% have actually initiated a blockchain deployment. While blockchain is gaining traction and acceptance in more industries, there are still some challenges left that need to be fixed first before we will see a large-scale deployment. Let's take a look at 7 blockchain challenges that need to be fixed. Scalability. The first challenge is the technical scalability of blockchain, which is, at least for public blockchains, a hurdle that could limit their adoption. For example, the Bitcoin blockchain is growing at 1 MB per block every 10 minutes and currently has a size of 241 gigabytes, while an Ethereum full archive nodes currently takes up over 3 terabytes of data. Nodes that want to validate transactions are required to download the entire Bitcoin blockchain, which could pose a problem in the long run. Of course, there are plenty of other blockchains that take a different approach and maybe require less storage. However, growth in data coming our way, 175 zettabytes per year in 2025, this could become problematic. Scalability is less of a problem for private blockchains such as Hyperledger, since the nodes in the network have a direct interest in processing transactions. This means the computational power required to validate blocks is less of an issue. If transactions cannot be verified in real time or within a short time frame, this affects the technical adoption of blockchain, as rapid decisions are often required, especially in today's high-velocity environments. The second challenge is related to the transaction speed of blockchain. In 2019, the Bitcoin blockchain is still capable of only processing 7 transactions a second, while the Ethereum blockchain could theoretically process 8. However, at the 2018 Singles Day in China, Alibaba processed 325,000 transactions per second, resulting in a revenue of $30.8 billion in 24 hours. Blockchain will take time to reach these levels. Meanwhile, new distributed ledger technologies are being developed that offer thousands or even millions of transactions each second. However, the deployment of these new distributed ledger technologies in enterprise environments is still limited. The third challenge involves the level of decentralization with the Bitcoin blockchain. Although this does not apply to all distributed ledger technologies, it is important to emphasize. The power of Bitcoin lies in the fact that it was designed to be decentralized, in that not one centralized stakeholder could control the network. However, today's mining pools nonetheless control a majority of Bitcoin's collective hash rate. 6 mining pools together control over 75% of the mining power. This centralization of validating transactions is a logical consequence of how the Bitcoin protocol was developed, as it rewards economies of scale. This does not have to be a problem as long as the mining pools can be trusted and have an incentive to do the right thing. Of course, decentralization is tackled differently when it comes to private blockchains. Since everyone is known in the network, it does not matter if only a dozen nodes control the network. However, such as Facebook aims to develop a global cryptocurrency Libra using a private network with a maximum of 100 players to begin with, this can be considered problematic. Only fully decentralized blockchains are temper and censorship resistant, and so far there are only limited examples of truly decentralized blockchains. Lack of talent, the fourth challenge from an organization design perspective. Lack of talent, the fourth challenge from an organization design perspective is the lack of talent to build decentralized applications. Educating employees to work with blockchain takes time. However, it is not yet taught at many educational institutes. Only 50% of the world's top universities offer a blockchain course. As is the case with all new technologies, organizations and academia need to work together to ensure the correct curriculum is introduced. There are already hundreds of blockchain startups all trying to attract the same limited talent. Yet, organizations are faced with a talent pool that is expanding more slowly than demand is growing. Therefore, organizations that want to embrace blockchain technology need to have deep pockets to pay for expert salaries or rely on employees that have only just started learning this new technology. The ecosystem. The fifth challenge is that a decentralized ecosystem surrounding blockchain and supporting distributed products and services is needed. This includes decentralized cloud storage, currently being developed by companies such as Ethereum, and the Interplanetary File System, also called IPFS. Also, decentralized archiving, decentralized communication, and decentralized domain name servers are other requirements. Most of these technologies are not yet fully developed, resulting in significant risks for anyone who wants to get involved with blockchain and develop completely decentralized and autonomous organizations. However, the decentralized ecosystem consists of multiple layers, which many of these layers are still under development. Infrastructure layer. Those applications that aim to create an infrastructure layer on which others can develop applications. Public blockchains include Ethereum, EOS, and NXT, while private blockchains include Ripple, Hyperledger, multi-chain, and chain. Consensus mechanisms required to ensure the state of the network and to determine which node can validate transactions. There are numerous consensus algorithms available, ranging from proof of work or POW, proof of stake or POS, and many others. Distributed computing. Using distributed ledger technology to distribute your computing requirements, basically cloud computing but then decentralized. Example includes Golem or Sonem. Distributed storage. Distributed data storage is especially important when you want to be sure that data can always be accessed regardless of restrictions some countries have. Examples include Storj, IFPD, and Filecoin. Privacy and identity. Services that are focused on developing a self-sovereign identity and ensuring that data of